All right, guys, now we are going to go over the Newton's second law practice worksheet. What's really helpful about this is it gives you all of those equations. Remember my trick, though, with the triangle, okay? If we know that force equals mass times acceleration, we put what we want to multiply at the bottom, mass times acceleration. We put what we want at the top because that's going to be divided by each of these. So, force is equal to mass times acceleration. Acceleration is equal to force divided by mass, and mass is equal to force divided by acceleration. Or you can just memorize these. But I would recommend being able to rearrange these because all I'm going to give you on this assessment is force equals mass times acceleration. You will be responsible for rearranging that equation. So let's go through a little bit of a review first. What is a force? Guys, all a force is a push or pull on an object resulting from an object's interaction with another object. What is the SI unit for force? Guys, every single time I ask students about this, they say F. F is not force. F is the variable we use to identify force. The SI unit for force is saying the standard international unit, just like the SI unit for mass is going to be kilograms. What is the SI unit for force? It's N, otherwise known as newtons. All right, I want you guys to think about this. As acceleration increases, does the force get bigger, get smaller, or stays the same? So let's think about this. If force equals mass times acceleration, and our acceleration increases, what's going to happen? The mass stays the same, but the acceleration increases, that force is going to increase. It's going to get larger. Okay, go ahead and answer those two questions on your own. Let's go through a couple of these problems. Number 5, what is the net force, or what is the force that is required to accelerate a car at a rate of 2 meters per second if the car has a mass of 300 kilograms? So we're looking for force. We don't know what force is. But what do we have? We have the mass is 3,000 kilograms. We also have that the acceleration is 2 meters per second squared. Guys, if we know that force equals mass times acceleration, all we have to do is take the mass, which is 3,000 kilograms, and multiply that by the acceleration of 2 meters per second squared. 3,000 times 2 gives us 6,000. And what is the unit for force? Newtons. Exactly right. All right. Number 7. Let's skip number 6. You can do that on your own or check the key. Number 7. Sally has a car that accelerates at 5 meters per second squared. So we know that the acceleration is 5 meters per second squared. If the car has a mass of 1,000 kilograms, so a mass equals 1,000 kilograms, how much force does the car have? So again, we're going to be solving for F in this example. If I can straighten out the video camera, that'd be great. All right, so we don't know this force. We do know, though, that the force equation equals force equals mass times acceleration. And we have mass and we have acceleration. So force is equal to the mass, which is 1,000 kilograms, times the acceleration, which is 5 meters per second squared. 1,000 times 5 is 5,000. And what are our units for force? Newtons. All right, go ahead and flip over that page. Let's do a few on the back. These top ones are a lot like what we just did on the other page. This is a force problem. This is a force problem. This is where you're going to start having to rearrange things. So I'd like to start here on number 10. A crate is dragged across an ice-covered lake. The box accelerates at 0.08 meters per second squared, so that's our A, and is pulled by a 47 Newton force. What is the mass of the box? So we don't know what the mass is. We do know that the acceleration is 0.08 meters per second squared. We know that the force is 47 newtons, but we have no idea what this mass is. I want you guys to remember the triangle. Force, mass times acceleration. We're solving for mass. So if force equals mass times acceleration, and acceleration equals force divided by mass, mass would equal force divided by acceleration. So we know that mass is equal to force divided by acceleration. So all we have to do is take the force, which we know is 47 newtons, and we know the acceleration is 0.08 meters per second. 0.08 meters per second squared. So we have to plug this in. 47 divided by 0.08, you get 587.5. 587.5. What are our units going to be if we're measuring mass? Kilograms. Alrighty, let's do number 11. A boy with a mass of 40 kilograms, so that's our M, is riding in a wagon pulled by a horse. The wagon has a mass of 40 kilograms. What is the acceleration of the wagon if the boy and the horse pulls with a force of 30 newtons? This seems like a lot because we've got two masses. But let's break this down a little bit. We already know that force is equal to mass times acceleration. The only difference here, guys, is we need to combine the masses because, look, it says the boy and the horse pulls with 40 newtons. Okay? So we just have to add these together because the boy's on the horse. So 40 plus 300 would give us a mass of 340 kilograms. Our force is equal to 30 newtons. Okay? So we need to find the acceleration. If we're looking for the acceleration, it equals force divided by mass. So acceleration is equal to force divided by mass. So then the force would be 30 newtons. The mass would be the total mass, which is 340 kilograms. Go ahead and plug that in. We've got 30 divided by 340. We get 0.88. 0.088. I would just round that to 0.09. So your final answer for acceleration is 0.09. What is the appropriate SI unit or the standard international unit for acceleration? Meters per second squared. Guys, when you're taking an assessment, remember, these are here. These SI units are reminded in all of these different problems. Let's say you don't remember that, but you know you just solved for A. All right, well, we know that A's units were up here, okay? We know that when we're solving for mass, we have problems with mass in it, and it says kilograms. So be aware of those units and those little hints throughout your assessments. Okay, let's go ahead and solve for number 13. What is the acceleration of a softball if it has a mass of 0.5 kilograms, so that's our mass, and hits the catcher's glove with a force of 25 newtons? So we're looking for that acceleration again. Acceleration is equal to force divided by mass. So all we do is you take that force, 25 newtons, divided by the mass of 0.5 kilograms. Type it in. 25 divided by 0.5, 50. What are the appropriate units for acceleration? Meters per second squared. Perfect. All right, if you've got questions, come on in and see me.